Okay, so this is an R formula question that relates to the topic of trigonometry for additional mathematics. This is the actual question that came out in O Levels 2018, paper 2, question 5. So let's read the question. The diagram above represents the path of a skier. He takes the lift from A to B, a journey of 800 meters along a slope inclined at theta degrees to the horizontal. From B, he skis 1,200 meters downhill to finally reach D after passing through point C. The points E, C, and A are at the same level, and E is 200 meters directly above point D. First question, given that angle ABC is 90 degrees, express BC in terms of tangent theta, and hence obtain an expression for CD. Okay, so very quickly, we know that triangle ABC is a right angled triangle, okay, whereby the right angle is right here. Okay, that is the right angle. Okay, so we are supposed to express BC in terms of some trigonometric ratio, and that is actually tangent theta. Right, so with respect to theta, BC is known as the opposite length, and 800 is known as the adjacent length. AC is known as your hypotenuse. Alright, so if we use tuakaso, and so, okay, so SOH, and since we are targeting to find tangent theta, we focus our efforts on the first ratio here. Okay, so for part 1, tangent of theta, okay, is equals to the opposite length, which is BC, over the adjacent length, 800 meters. So BC is just 800 multiplied by tangent theta. We have done a very simple cross multiplication here. Okay, so that is the answer for BC. So BC is done. That is having a value of 800 tangent theta. And the next part of part 1 is asking us, hence, obtain an expression for CD. Okay, so CD is basically this green line right here. Okay, in the question, they have mentioned that from point B to point D is a total distance of 1,200 meters. Okay, so to find CD is basically just a subtraction of 1,200 and 800 tangent theta. Why? Because this green line added up with this blue line will give us 1,200 meters. Okay, so to find CD, it is 1,200 minus away 800 tan theta, and that is the complete answer for part 1. Okay, let's look at part 2. Hence, show that DE can be expressed in the form A cosine theta plus B sine theta, where A and B are constants. Okay, so now they are targeting to find DE. Okay, before we find DE, okay, we must realize that there are some similarities between triangle DEC and triangle ABC. Now, what is the similarity? The similarity is really the angles, okay? So, if you look at angle BCA, okay, angle BCA is just 180 degrees minus 90 degrees minus theta, which is at the end just 90 degrees minus theta degrees. Okay, if you're fast enough, you can even skip this step for a right angle triangle and jump to this step to find the angle BCA. Right, so if BCA is 90 minus theta, angle ECD is exactly equals to angle BCA by virtue of vertically opposite angles, right? So this angle right here is also 90 degrees minus theta degrees. And with that, I can actually find the remaining angle, which is angle EDC, right here. Angle EDC is just 180 degrees minus 90 degrees minus that 90 degrees minus theta. Please put a bracket here. Okay, so at the end, EDC is also theta degrees. Right, so over here is actually theta degrees. And over here is 90 minus theta, as we have said earlier. Same thing for here, 90 minus theta. Okay, so the next step is to try our best to find the value of dE using some trigonometric ratios again. So again, we are supposed to use our part 1 answer. So basically in part 1, we found BC, we also found CD. CD is right here in this green line. The green line's value is 1200 minus 800 tangent theta. Okay, so with that, I can express dE in terms of some trigonometric ratio. So I'm going to redraw the triangle EDC. So triangle EDC is right here. Okay, my target is to find this red line here. And the good thing is I already have this angle, which is theta. And in addition to that, I have the length for CD as well, which is 1200 minus 800 tangent theta. Okay, so if you want to find the red line with respect to the theta, the red line is your adjacent, and the green line, which is something that you have, is your hypotenuse. So going back to Tuakaso, this time around we focus on the second trigonometric ratio, which is K. Okay, so cosine theta is equals to the adjacent length, which is dE, over the hypotenuse length, 1200 minus 800 tan theta. Okay, so with that, I can very quickly find dE by again doing a cross multiplication. So dE is equals to cosine theta times 1200 minus 800 tangent theta. Okay, but hey, in the question, they have actually mentioned that dE is to be expressed in cosine theta and sine theta. There is no tangent theta involved in the final expression. So what we do, we change the tangent theta that we have into sine theta over cosine theta. 800 sine theta over cosine theta, and then we do a simple expansion. So we expand the cosine theta inside, and the final value for dE will just be 1200 cosine theta minus 800 sine theta. Okay, because the cosine theta right here and the cosine theta right here at the denominator cancels off. So yeah, this is the final answer for part 2. We have managed to express dE in terms of A cos theta plus B sin theta, where A and B are just some numbers, some constants. Okay, so that is the solution for part 2. Again, part 1 and part 2, we have managed to solve it. Next part, part number 3. Okay, now let's target to finish that part 3. Now, by expressing dE in the form r cosine theta plus alpha, find the value of theta. Again, dE has been found in part 2, that is 1200 cos theta minus 800 sine theta. So let's do part 3 at the side here. Okay, part 3. dE is equals to 1200 cos theta minus 800 sine theta, and I'm supposed to express this in the R formula. So the R formula is R cosine theta plus alpha. Now I encourage you, whenever you come across this R formula question, that you start by looking at the formula. So I want to change the dE into R cosine theta plus alpha. Definitely all these 3 formulas are not applicable for this particular question. Even this formula is not applicable. The only one that I have to zoom in on is this guy right here, which says cosine A plus B equals to cosine A cosine B minus sine A sine B. Right? So the first step that you will have to employ is this. R cosine theta plus alpha has to be split out according to my formula right here. So let's split it out. So the R is just left outside, and what you have to split out is your cosine theta plus alpha. So theta becomes your A and alpha becomes your B. Alright, so theta becomes A, alpha becomes B. So R, put a big bracket here, cosine A plus B is equals to cosine A cosine B minus sine A sine B. Okay, why minus? Because we have to follow the order of the formula. If you look at the formula, cosine A plus B, there is a minus there. And if it's cosine A minus B, it's going to be a plus instead. Right? So what is the next step? The next step is to multiply your R back in. So this is equals to R cosine theta cosine alpha minus R sine theta sine alpha. And again, this has to be equated to my original DE equation. So what do I mean by that is, let's go back to our original equation right here. Okay, let's label it as equation 1. So from equation 1, what do we have is 1200 cosine theta minus 800 sine theta will be equals to R cos theta plus alpha, right? Now this part here, we have already split it out into this part. So this is the same as R cos theta cos alpha minus R sine theta sine alpha. Right, so the next step is to come up with some partners. Now what do I mean by partners? The partner or the coefficient, okay, the coefficient of cosine theta on the left side is actually 1200. For the right side, the coefficient for cosine theta is R times cosine alpha. So we can do a simple rearrangement first before we find the coefficient. We can rearrange the equation to become like this first. Okay, and then again we can write this down so that we can compare easily from the left and the right. Okay, so just by comparison, again, the cosine theta is here, the cosine theta is here. Comparing coefficients of cosine theta, 1200 has to be equals to R cosine alpha. Okay, and also we do the same thing for sine theta. So for sine theta, negative 800 is equals to negative R sine alpha, just by comparison of your sine theta coefficients. Okay, so negative 800 is equals to negative R sine alpha. Negative cancels off. So basically we have some nice equations to work with right now. So 1200 equals to R cosine alpha. And the next one is 800 equals to R sine alpha. Okay, but this is not the end, because at the final solution, I need to find the value for R. I also need to find the value for alpha. How do we go about finding R and alpha? This becomes equation 2. This becomes equation 3 now. Okay, so from here, we have to use some trigonometric formulas to help us. Okay, so to find alpha, we need to work with just one trigo ratio. At the moment, there is cosine here, there is sine. So we need to somehow find a way to combine these two and make it into one equation, one trigo equation. And ask yourself, what is the trigo ratio that links sine and cosine? That is actually tangent. So how do I get a tangent? I need sine to be divided by cosine. So basically, I need equation 3 to be divided by equation 2. So that gives us R. Okay, we can start with the left, no problem. So if you start with the left side, it's 800 over 1200 is equals to R sine alpha over R cosine alphas. The R cancels off, and this part here, you can quickly visualize this to be tangent alpha. Right, so this 800 over 12 can be simplified to 2/3. Okay, so you have 2/3 here, and that is equals to tangent alpha. Right, so from here, very quickly, we can find the value of alpha, which is just tangent inverse 2/3. Okay, Okay, and that will give us a value of 33.69 degrees. Right, so the next challenge for us is to find the value of r. Again, we need to somehow work with a trigo formula to help us find the value of r. This time around, we must try to eliminate or take away sine and cosine. And the way to do that is to use this formula that we actually cancelled out earlier. This one right here. Okay, this one that says sine square A plus cosine square A equals to 1. We got to use that formula to help us out. And the way to get a square is to square the equation itself. So what you have to do is take 3 square plus 2 square. Because when you take 3 square plus 2 square, you're going to get sine square, you're going to get cosine square. When you add them up together, they are just going to get a value of 1. And from that 1, you basically eliminate cosine and sine already. Okay, so equation 3 square plus equation 2 square. So equation 3 square is 800 square plus equation 2 square is 1200 square. And that is equals to r square sine square alpha plus r square cosine square alpha. 800 square plus 1200 square is equals to r square sine square alpha plus cosine square alpha. I've just factorized the r square out. Sine square alpha plus cosine square alpha is just equals to 1. 800 square plus 1200 square is equals to r square times 1, which is just r square. And then r square is as simple as 800 square plus 1200 square. R is just the square root of this whole bunch of terms. Okay, and if you simplify these surds, you will be able to get a value of 400 square root 13 in exact form. So there you go, you have found the value of r already. Okay, of course there is a shortcut to the r formula, which I'm going to write here, which is if you have a cosine theta minus b sine theta, okay, and that is equals to r cosine theta plus alpha, right? You can find r very simply by doing this a square plus b square. If you observe, this is what we ended up with. Okay, we ended up with r equals to square root 800 square plus 1200 square. That is your a and b values. And you can also do the same thing to find the alpha. There is also a formula for that. Tangent alpha equals to b over a. Okay, you can definitely use this in the examinations, but I highly encourage that you present your answer in this way so that the teacher knows that you are aware of how to employ this formula. Okay, if you are fast, these formulas, or rather these steps, are just going to take you 1 or 2 additional minutes, but it shows a lot more as compared to just using these formulas. Okay, so r is given already. We have alpha. We can therefore express dE in terms of r cosine theta plus alpha. Alpha is 33.69 degrees. Alright, so that is the first part of the part 3. And the last part of this particular question is to find theta. Now, how do we find theta? In the question itself, let's look at the question. We are actually given the value of dE, which is right here. Let me just highlight it. Is 200 meters. Okay, so from here we can equate our r formula to 200 meters. For 100 root 13 cos theta plus 33.69 degrees is equals to 200. Alright, so cos theta plus 33.69 is just equals to 200 divided by 400 square root 13. And then we can certainly find theta just by doing a cosine inverse. Theta plus 33.69 degrees is just cosine inverse of this whole bunch of terms. 200 and 400 cancels off, becomes 1 over 2. So 1 over 2 square root 3. And then theta is just cosine inverse 1 over 2 square root 3 minus away 33.69 degrees. At the end, we will get a final answer of 48.3 degrees corrected to 1 decimal place. Okay, so before this correction to 1 decimal place, please present your answer in 4dp first. Okay, present your answer in 4dp and then round off to 1 decimal place to get the final value of 48.3 degrees. Okay, so there you have it. This is actually 2018's O-Level, paper 2, question 5 on the R formula. It's worth 10 marks. Okay, thank you very much.